the more we can reduce energy use at wastewater treatment plants, which are big users, the more of an environmental impact there is. But also from a financial perspective, for the municipalities that own and operate these plants, this could be a big money saver. Energy, as I understand it, is often the largest component of the cost of running one of these wastewater treatment plants. So it can make a big impact on the bill.
Welcome to Growing Impact, a podcast by the Institute of Energy and the Environment at Penn State. Each month, Growing Impact explores the projects of Penn State researchers who are solving some of the world's most challenging energy and environmental issues. Each project has been funded through a Seed Grant program that's facilitated through IEE. I'm your host, Kevin Slack. For many people in the U.S., unless you have a plumbing issue or you smell sewage, wastewater is not on your mind. Once it leaves your home, you don't think about it again. But turning wastewater into clean, safe water is energy intensive. It can account for more than a third of a municipality's energy usage. It's also a necessity. Water treatment must be able to function no matter what. So if there's a power outage, a water treatment plant has to have a backup. Most treatment plants run on energy generated from fossil fuels or nuclear power, but some are using renewable energy, specifically solar energy. On this episode of Growing Impact, I speak with Christine Kirchhoff, Kim Van Meter, and Hannah Wiseman, three researchers who aim to develop a database of wastewater treatment plants that are using solar energy. They also look to explore what drivers affect solar adoption and the resulting energy justice implications.
Can everyone introduce themselves and just provide a brief background on your research? And I will start with Christine.
Sure, Kevin. So I'm an associate professor of civil and environmental engineering and law policy and engineering. So in the College of Engineering. And previously I was at the University of Connecticut. I haven't been here that long. There I was in civil and environmental engineering, an associate professor and a Castleman professor of engineering innovation. And I'm sort of an unusual engineer in that I do interdisciplinary social science research in the context of engineered or built infrastructure. And so that is sort of the human dimensions of engineering piece, and climate adaptation / resilience, mitigation, adaptation is sort of embedded in this project in particular. In addition to that sort of area or domain, most of my work is in environmental and water governance and policy, and on adaptation, decision-making, and transformation, trying to move the needle for infrastructure to adapt to climate change.
Kim, could you go next?
So my name's Kim Van Meter. I'm an assistant professor in the Department of Geography here at Penn State. I'm also an associate in the Earth and Environmental Systems Institute. I work broadly in the domain of water system science. A lot of my work is related to creating computer models to try to understand how we can improve water quality or provide better access to water resources. I'm increasingly working with a lot of remote sensing imagery, so satellite imagery, and using machine learning or deep learning kinds of techniques to work with those big data sets.
And Hannah, would you mind introducing yourself?
Thanks, Kevin. I'm Hannah Wiseman. I'm a professor in the law school at Penn State and in the College of Earth and Mineral Sciences. I work primarily on legal and policy issues relating to energy infrastructure. I explore both the fossil fuel sector, but primarily the sectors that are becoming more important as we transition away from fossil fuels, so zero carbon energy sources like renewables. And I'm most interested in the local level. I look at the national, state, and local level, but I'm particularly intrigued by creative solutions that local governments are finding to enable energy infrastructure, but also the not in my backyard attitude that many communities also have, even for energy technologies like solar and wind.
So I have to say, for an interdisciplinary team, this is a very interdisciplinary team. You have three very different backgrounds coming together on a very interesting project. Could we talk a bit about the basics of wastewater? Speaking for myself, I understand that, wastewater leaves my house or leaves a building, it goes through pipes and it gets treated in some way, shape, or form. And I suspect a lot of people are probably in my boat that don't understand the capacity, the resources, the energy, the time, et cetera, that goes into actual wastewater treatment to actually get it out and put it into the environment again, where it can be either that nature can take care of it, or it can be used by humans, or whatever it is. So would you mind, can we start with the real basics of wastewater treatment and why maybe this was an area that that deserves attention?
So there's tens of thousands of wastewater systems across the country. They're regulated by the Clean Water Act, so through usually devolved to the states to ensure that what they discharge to the environment, regulated through these things called National Pollutant Discharge Elimination System permits, typically. And so that regulates the quality of the water that is discharged to the environment. So you mentioned you flush the toilet. So if you are in a community that's served by a wastewater treatment plant, when you flush and your neighbor flushes and I flush, and it all gets collected to one facility for that community, and then that facility takes out the big stuff, the things that shouldn't be in there or that find their ways in there, and that and sand and the grit is removed up front so that that protects all the pumps and the piping and machinery that comes later. But most of this is through an organic process. So we typically use bacteria to eat the organic matter that's coming in, and gravity to settle out the big particles and things as it moves to the treatment train, and some chemicals that are added to disinfect and deactivate the bacteria and virus and protozoa that also work into that waste stream, and filtering. And so that by the time that it reaches the discharge pipe, it is clear. Usually it's quite clear. It looks like clean water. The chemical tests indicate that it's clean water and ready to be released into the environment. And so that's what a pretty typical wastewater treatment plant kind of does. But all of that machinery that I mentioned, the organic processes require typically a lot of aeration, which is typically done through some mechanical process. So say some series of blowers that use a lot of energy to push air up through the water to create that oxygen-rich environment that the bugs need to reproduce and do the eating and things that's part of this wastewater treatment process. And then the pumps, and it's not just at the plant. There's also pumps that are in pump stations, in the community, depending on gravity. How if there are parts of the community that are up high, it can travel all the way by gravity. But if there are parts of the community that are, say, in a different elevation, there physically are pump stations that lift and push that wastewater into the plant. But all of those things, you can imagine just a ton of working parts at a plant that use a lot of energy. Hence the value of the wastewater systems for cleaning the water, but also the need to think about the energy demands that are used by those wastewater systems, not just here in Pennsylvania, but across the country.
I want to add a little bit to that, Christine. So I work a lot on Chesapeake Bay water issues. And, one of the super important things about wastewater treatment is that we want to clean this water up so that we're not getting a lot of excess nutrients going to the bay that cause the bay to be in bad ecological shape. And we have done a lot to upgrade our wastewater plants. More can be done, but often one of the limiting factors in increasing the efficiency of removing these excess nutrients or contaminants is the energy limitation. It takes a lot of energy to remove more of these nutrients, and having solar as an option to potentially give an affordable energy choice can make a difference.
And I'll just add that wastewater treatment plants are an important part of what we often call the water energy cycle. So it takes a lot of energy to pump the fresh water to our homes that we use in our showers and sinks and toilets. And then it takes a lot of energy to treat that water. And in turn, it takes a lot of water to generate the electricity for the pumping, especially at any steam power plant, whether you have a coal or a natural gas fired power plant. One other benefit of solar, the most common form of solar energy, is solar photovoltaic power. Those are the panels that many people have probably seen on rooftops of homes. Those do not use water. Unlike a lot of the centralized fossil fuel fired power plants, solar photovoltaic panels use a special reaction within the cells. The sunlight goes into the cells and directly generates electricity.
Yeah.
And I think that's really interesting. It's like breaking that water energy nexus connection there a bit when, introducing solar energy into the mix.
Right. And,
Cool.
and if I may, we're talking about things that are leaving the water that leaves our buildings, but in addition, the water that is going into like storm water that is running off of roofs or off of parking lots, et cetera, can also end up in these places. So we could, if a place is inundated with a large storm, right, we have even more water to deal with. Is that accurate?
Yeah.
And you can say no too. You can tell me, no, you're completely wrong.
It depends on the
It
city.
depends.
It depends. Okay, that's fair. I like that.
It depends. You can have really leaky systems, for example. I mean, one of the things with climate change is you might have areas that are now flooding that weren't historically flooding. And so then you could have I don't know why it's escaping me now, but the manhole covers that are in streets. And typically it's been dry for the last 100 years, but over the last 10 years, whatever, it's starting to get inundation, but these manhole covers aren't built to actually be submerged. So then that provides a direct conduit of whatever flood water accumulates in the street gets right into the system. And the system, a separate sewage system, is not designed to take in all of that water. And the challenge there is like it's dilute. A separate sewage system is used to seeing nice concentrated flow when you flood, of household and other types of waste streams. So that stormwater is not meant to really go into those separate systems, but there are combined systems that were built originally as these bring in the stormwater, bring in the wastewater. They get overflows, and there's challenges there too. But Hannah, I didn't know if you wanted to jump in.
I was just thinking of the combined and separate distinction that you talked about. So depending on where one lives, the wastewater treatment facility is designed to accommodate that stormwater, the water flowing over roofs and over land, as Christine noted, or it's not intended to take in that stormwater, in which case the stormwater sometimes flows directly to a creek. Or so if anyone sees those little placards on the stormwater drains with a fish or a frog, that's sometimes indicating that stormwater is not getting much, if any, treatment before going into a water system in the natural environment.
All right. So you've already alluded to that this process is I can't think of the word. It uses a lot of energy.
Energy intensive.
And thank you. I appreciate that. So could you discuss a little bit about where, because it is so energy intensive, where and how that opportunity popped up as this could be a project where we could focus on and actually make a difference?
I'll start.
Hannah, do you want to take it first? Yeah.
Sure. I think from an environmental, monetary and business perspective, it makes sense because environmentally, right? When you have something that's a large energy user, it's also a large greenhouse gas emitter and emitter of other conventional pollutants. So the more we can reduce energy use at wastewater treatment plants, which are big users, the more of an environmental impact there is. But also from a financial perspective, for the municipalities that own and operate these plants, this could be a big money saver. Energy, as I understand it, is often the largest component of the cost of running one of these wastewater treatment plants. So it can make a big impact on the bill.
Yeah, absolutely. I think it's something that in part it hasn't been historically as recognized. I think as energy costs continue to rise, I think municipalities are feeling a larger and larger squeeze by these rising energy costs, these facilities that have to run, and if business as usual continues, they're going to gobble up more and more of a municipality's budget just to do what they have to do it because they are required to meet those permitted limits at the end of the pipe. And so I think for the cost savings, there are the environmental co-benefits, greening also, is also sort of part of that. But then if we think sort of a step further on the resilient side of things, these systems are designed to be reliable, so to be working even when the power goes out. They usually have backup generators, which themselves are sources of greenhouse gas emissions because they're usually more polluting types of energy driving those generators. But solar, here's where renewables could come in, could provide that backup. But this sort of the situation repeats itself again, tens of thousands of times across the country, where you see these, increasing energy demands and costs really putting pressure on these municipalities that largely aren't year after year getting more money. If anything, year after year, the pool of resources that they have is shrinking. And so this is a real key, touch point or sweet spot where there's a lot of potential, but it surprisingly hasn't been well studied. So.
And I believe it was in your abstract that I saw this, that some municipalities have that wastewater treatment plants can be responsible for like 30% or more of a municipality's energy use, which is, that's a third of the use. A third of the energy use is going just to the wastewater treatment plant. So all of these things you're talking about, to put in perspective, like that's a third of the energy use seems it's a tremendous portion of it.
Mm-hmm.
So. Yeah, and I think it's worth directly stating here that solar is one of the cheapest forms of energy now. We didn't put that up front. I think that's largely in common knowledge, but just to clarify, the cost of solar photovoltaic panels has gone down so much that the reason solar is a good option for reducing these significant costs is because it's almost often the cheapest energy source available for a municipality.
Yeah. What else about solar is, or should I guess I should ask, are there other components or other facets of solar energy that are attractive to wastewater treatment plants, and maybe why it could also be, cost-wise, there's a clear reason, right? Economically, are there other reasons or other ways that solar could easily fit into wastewater treatment plants?
Well, I think the rooftop is an option. We're working on a project or a paper that's taking some findings from a master's student that I had at the University of Connecticut, and it seemed, at least in California, there was a sweet spot of like 1 to 10 MGD facilities. So it was like the bigger facilities can do other things. So one thing to sort of keep in mind is like there's anaerobic digestion and cogeneration. So the ability to sort of produce methane gas at a facility, if you're large enough, then that can be really a cost-effective source of energy for the facility that's generated on site, and that can be used to help offset the energy demands. But then as you get smaller, the cost effectiveness of those types of renewable energy options, they don't make as much sense. And here's where solar really could provide that sweet spot. And kind of backing up, with our facilities there's typically a regulation that requires a renewable or backup power supply. So that's why you get either supposedly 2 independent sources of energy, of usually fossil fuel energy, coming into the facility in case one goes down. You can still run the plant. You have the backup generation. In my mind, solar very much can fit into that sort of backup power mode, where if the grid falters for some reason, now you've got this reliable source of, energy that's coming into the facility that can help backstop and provide that energy security piece too, I think is kind of an important thing to think about here.
I think that's an interesting point, Christine, about the size of the wastewater plants, because one of the things that I've seen in my work is that it tends to be smaller communities, more rural communities that have a harder time meeting the regulatory guidelines because it's expensive for them to do that. And it seems to me that solar might be a way for these lower income rural areas to do a better job of treating their wastewater.
Yeah, I think solar can be beneficial at wastewater treatment plants, especially because they can be both a money saver and a money maker for these municipalities. So a lot of states have policies that incentivize the installation and generation of solar power through net metering, for example, where any excess power generated by the solar panels can be sold back to a utility at a relatively strong rate that helps compensate that solar generator. And there are other incentives that could help these municipalities, again, not only reduce those energy costs, but maybe even make some money.
One more piece was, I think I started off by saying rooftop solar is one of the mechanisms for bringing solar into those sort of the facilities where that makes sense. But the other place we've seen wastewater systems, and again, this is based on the first go at this project last year, is in sort of nearby plots of land where you have a land-based solar array that provides power to the facility. So it doesn't have to be rooftop in the facility, because sometimes building that in to existing infrastructure and existing building stock can be harder. If there's land available and it makes sense, it can be installed adjacent. But doing all these things that we've been talking about.
If a wastewater treatment plant takes 30% of a municipality's energy, that's a lot of energy. Can solar actually meet that demand?
Solar, to me, is one piece of the puzzle for the energy demands at wastewater plants. There's a whole nother, I think EPA and DOE are funding sort of, how do you do new tech, less energy intensive wastewater treatment? So to me, solar is a piece of the answer. It may not be the entire answer. Part of it is energy efficiency at the facilities. Often low-hanging fruit has not even been, approached, because wastewater operators don't, that's not their job. Their job is not about reducing energy at a facility. It's about ensuring they comply with the NIPD's permit. This is, I think, one of the things, sort of mindset that needs to change is, how do we change that paradigm so that we are thinking more about energy efficiency at wastewater plants and renewable energy and carbon accounting and adaptation across the board, right? But so energy efficiency, I think, is part of the answer. Maybe down the line, new technologies are just more energy efficient overall, and they do this sort of process and need less energy. And then I think the renewables play a role in this as well. And I think Hannah pointed out that it can be a money saver and a money maker. And the resilience energy security piece, I think, is really key here, which we're not thinking enough about, is, and we see this in Florida, one of the only houses, and this was residential solar, everyone went, the place was devastated, but this one house had solar panels, and the community could charge their phones and things in the middle of this disaster. Wastewater plants can operate still, because if, everything else isn't been, crushed to smithereens, but they're still able to treat water and protect the environment, as Kim pointed out, the need that, at the end of the day, we still do need to think about environmental and public health aspects of wastewater treatment. So, I think solar is definitely in the mix. It may not be the end all, like the only solution here.
Are there examples of wastewater treatment plants that are doing this currently, whether in the US or other places in the world? Anyone who's successfully started to implement or add solar into their energy portfolio?
Yes, there are examples both in the United States and globally. in places one might not expect. So of course you see these in California, but also, as I understand it, Missoula, Montana now is a successful behind the meter facility, which means the solar power is actually directly feeding the wastewater treatment plant. So in some cases, wastewater treatment facilities are, the municipalities are installing the solar on site and directly consuming that electricity. In many other scenarios, the municipality is entering what's called a power purchase agreement with a solar developer. And that developer, as Christine noted, will typically build a solar array ground mounted, meaning there are some poles and some panels on those poles. The array is often close to the wastewater treatment plant, and it can feed electricity to that wastewater treatment plant, but also back into the broader grid. And in that case, you don't actually know how much solar energy is really going to the plant, because the solar energy is going into the larger grid, but there's a contract specifying that the municipality is purchasing a specific amount of electricity from the solar developer. And that's the power purchase agreement, the long-term agreement. And as I understand it, that power purchase agreement, or PPA, is one of the more common models now being used by municipalities that want to enter into these solar arrangements for wastewater treatment.
I'll follow up here and say, I think this is actually a great transition question to start talking about the project itself, because when I think about answering your question, I think, yes, of course, there's places where this is happening, it's being implemented, but we don't have a great sense of how extensive this is. There's no national registry to show us where solar is being implemented at these plants. And I think the project is going to start moving us in a direction where we can start to really quantify where is this happening, to what extent is it happening, what difference does it make, and what are the issues that come up as a result. And probably Christine, you can speak to that more.
Absolutely, and thanks, I think, for bringing that up, because I think Hannah, you started off by sort of we know solar is happening in like places that we would expect, like California, because California as a state has pledged to, cut carbon emissions. They're looking at every sector, wastewater being one of the many that they're looking at, and then they have specific incentives to help solar, help wastewater systems adopt solar at their facilities, and it really seems to be helping the smaller systems where that sweet spot, where it makes a lot of sense for them to do it. Those incentives really make a difference. And then we were looking, at California and New York as part of the, entry into this larger interdisciplinary project. And, in California, our subsample was 40% of the systems we were looking at out of 100 had adopted. So almost, 1 out of every 2 systems. In New York, it was 5 out of 75. So the incentive structures, I think, to Kim's point about, we don't know broadly where these systems exist, where wastewater systems are really taking advantage of solar, and in particular, what's really driving those. So we sort of need the broad, understanding, the broad database that I think Kim and her team will help to pull together, and then Hannah is going to really help us understand sort of the policy picture. Where are those incentives, or how do we get those successes? And the same thing will likely not work in every state, right? So we will need different ways of doing this. But so this project is a way of, starting to make progress in that front, really understanding where solar is in the landscape with wastewater, how states and individuals, localities are doing this, and then how do we really make more of it happen? Quantify the benefits. I mean, I think there's a lot of offshoots that can happen from this project, but this is an important first step.
Can we dive a little more into that? Because you said there's lots of things that could come from it. So quantifying it and understanding where it's happening and how it's happening, what could that then lead into, or what could you foresee? I guess maybe my question is, who really could benefit from this, the information, and how then maybe could it be used to improve situations within municipalities or industry that is serving those communities?
I mean, one of the things I think about, and we haven't really talked about the equity dimensions, but trying to understand where it's implemented and how, what's facilitating implementation of solar, the benefits of doing solar to sort of make it better known, why go down this path, because it can seem daunting to many municipalities, actually. Again, it's not part of their wheelhouse typically. And so really trying to help municipalities and wastewater systems in particular really understand, why should you think about doing this, and what are you going to gain from it? And here's a bunch of systems that have done it and are benefited that you can talk to. You don't need me to tell you, but go talk to them. And so I think that's a key piece to it. One of the things that we're seeing is in the study that I keep sort of referring to is that it does seem like it's helping. It's the benefits of renewable energy adoption seems to be going to not necessarily the lowest income, but a higher percentage of African American communities are able to take advantage of, I think, the incentives that California in particular provides, and lower, but not low, not poverty level income, but so it might be indeed filling these gaps that these resource constrained communities face, not just in wastewater, but in other parts of the community. So solar could be a piece of that puzzle, as Hannah has mentioned multiple times, about saving the cost savings, the energy security, as well as broader environmental benefits that that will help the community sort of writ large. And I think the database will help us explore those kinds of questions more broadly, and again make the case for why this has benefits. And I can think of a gazillion others, but I'd rather others speak to their notions of what this could lead to.
Well, I want to echo what you're saying a little bit, Christine. I see this in numerous sectors that I work in. It's when you start looking at these things at bigger scales and you see who is taking up these new practices, who is not. When you understand the gaps, it provides an opportunity for, I think, better understanding what kind of incentives could be created to get uptake in those areas. So the larger scale provides understanding that can then move towards action.
And ultimately, that understanding of the incentives that matter, my hope would be we could translate that into real policy options for municipalities and states. Some sort of toolkit indicating here are the important drivers. Now, of course, this will vary depending on the jurisdiction and the technologies and policies already in place, but to provide this menu of considerations and options to think about if a municipality is considering this solar pathway for their wastewater treatment plant. And there are lots of factors there that I think could be better fleshed out. From do we build this on site with a backup battery behind the meter where the solar energy is directly feeding in and providing those resilience benefits that Christine noted? Do we prefer a power purchase agreement where a solar developer builds it and sells the electricity and the municipality doesn't have to worry about any of the operation and maintenance of the solar panels over time? And what incentives from the state level or even the federal level have tended to be most effective and helpful in driving the development of solar energy at wastewater treatment plants, as well as the policies that are serving as barriers in some cases, of which there are many.
You started touching on equity and justice. And I think for some of us, we're unaware of how renewable energy, the transition to renewables can be challenging for some, but it can also offer opportunities and positives in other ways. Can we discuss a little bit more of that? Can we talk about how equity and justice is impacted by renewable energy?
Sure. At a broad level, I think there's often a tendency to think that the energy transition is all good for everyone, which ultimately it is. From the perspective of climate change is one of the biggest challenges of our time. It is affecting everyone, and it is in fact disproportionately affecting low-income communities that often don't have the resources to adapt as quickly to flooding and drought and other climate impacts. But when we look at the tools necessary to get us to a lower carbon world, building more renewable energy, for example, there can be disproportionate impacts of that transition that can once again fall on the communities we're intending to benefit with these policies. So if we have disproportionate siting of large-scale solar facilities in certain communities, or the transmission lines necessary to carry electricity from these massive solar farms to population centers, then we might have communities that already bear a disproportionate infrastructural burden. Maybe they already have pipelines and other energy infrastructure. Maybe we're piling on yet another burden in this case without adequately considering how many jobs or other benefits are flowing to those communities. So it's just important to think about, as we move toward these important new technologies such as solar to solve the broad problem of climate, for example, how can we do that in a more equitable way, which requires consideration of the impacts of the technologies themselves?
Yeah, we can't steamroll communities in order to meet this big macro need, right? We have to think about, to be mindful of all the micro details that are there that, you're right, I can only imagine get overlooked frequently.
And just one other central factor here is, of course, individual energy bills, right? I mean, and in this case, sewage bills, right? We want to make sure that if solar is being used as a money-saving mechanism, that those savings are being translated to individual consumers' bills. Because I think that's one of the greatest concerns of low-income individuals especially, is what am I seeing on my monthly electricity and sewage bill, because they tend to shoulder higher energy burdens, meaning a higher percentage of their income is going toward paying their electricity bill or for other necessities being provided by a municipality or a utility.
I would add, I think that was a lot of good information, considerations in that response, Hannah. I think I would add, in terms of like the small or primarily minority or marginalized communities, sometimes, and we see this, it's not just in this conversation or, with solar adoption, but just a lack of capacity to go after, a state agency incentive to adopt solar. You can't marshal, you may have trouble marshaling the expertise to put together a package to go get funds for solar energy. So the question, partly in my mind, in addition to not overburdening already burdened communities, or building an array that just bypasses the community that's sitting right next to you, is how do we ensure that a range of communities, particularly those that need it the most, one might argue, can also access these incentives? How do we really make it happen for all the communities out there, and maybe different things that need to be put in place to help different communities access those funds or access those incentives to make it possible.
So your project also seeks to understand what could enable or constrain solar adoption for wastewater treatment plants. This seemed like a large undertaking, from engineering to law to machine learning. Can we discuss the different areas and what the team will investigate?
As we said, we really don't know where we have solar uptake. And I can talk about the approach that we'll be using to try to do that identification of solar.
Yeah, I mean, Kim, I think that's a great thing to sort of talk about, is how do we develop this data set? I mean, we were talking in the proposal about developing the your team, you leading really the development of identifying the co-location or of the solar with wastewater plants, and I think Hannah leading the effort to understand the policy incentive piece of it. And I think one thing to preface your work, Kim, is to say in prior work around wastewater systems, I think Kim has found this to be similar in the work that she's done for the Chesapeake, is that, you know, there's a broad database, a federal database, the ECHO database, that lists all the wastewater systems. In fact, any sort of federal permit, any federally permitted facility is in this big database. There's industry, there's all kinds of things, including wastewater. And but often the location information that's included in those in that database is not necessarily the location of the wastewater facility itself, where you might find, where we want to understand if that solar is either in the roof, on the rooftops, or adjacent to the facility. And so part of the sort of the pre-step is you really identifying where those facilities are physically located. So then we can, Kim can work her, I'm going to call it magic, which is going to be a total disservice to what you do. But, you know, having a process to automatically identify those locations. So first we have to figure out where the plants are, you know, make sure that we know where they are. And then, you know, Kim can do her work.
Right, and I am completely comfortable being with you saying that I'm doing magic. Like that. But what we are doing, as you said, we start out with addresses or latitude, longitude points, and we can map those. There is some, you know, kind of tedious work where we can really just like zoom in on the imagery. You know, imagine going to Google Maps and looking at every address and saying, is there really a wastewater treatment plant there? So that's kind of the first question. But then the next question is that wastewater treatment plant utilizing solar? So we have to have a way of identifying those solar panels. And to do that, we are using satellite imagery, and we're using something that we call a deep learning approach. What is that? It's kind of it's a modeling approach in which we are trying to recognize objects. So imagine trying to teach your computer to tell the difference between a cat and a dog. You give it lots and lots of pictures, and through trial and error, your computer will learn how to do that. We're doing something very similar with this. We will give the model that we're developing training data with images where we know that there are wastewater plants with solar installations, and we'll allow that model to learn. And eventually then we will be able to work over larger areas, you know, starting in Pennsylvania, across the Northeast. And I know we're hoping eventually to do a more large scale analysis where we can use these automated models to identify these sites for us.
Great.
And I think we really want to get there because it's tens of thousands right across the country.
That's right.
We don't, I mean, we
That's
could
right.
get an army of undergrads or students to work on that for us. But I think if we can automate this in the way that Kimberly has described, I think we can get there perhaps faster. So.
Honestly, that's what I envisioned. I envisioned like 2 or 3 grad students or something sitting in a room poring over maps, like they're like looking at each other like, this is the worst summer ever.
And you know, to be honest, there's always a little bit of that because you have to create those training data sets to use, and you want to make sure that you're identifying something that's real. But yeah, hopefully we can work at much larger scales than that, and we don't make too many grad students' lives miserable.
It's a resume builder. It's a resume builder.
That's right.
All right. So let's talk about, at the end of this project, what will success look like?
I think definitely the database is because that is something I think, you know, as we go from a small scale to the large scale, ultimately, I think that large scale then is, you know, it's in the public domain. So for all the zillions of offshoots of things that people, I think, would take and run with that data. So I think that's a huge sort of public service goal. And I think I'm going to let Hannah talk about where you see success, and Kim, where you see success. That would just be one example.
For me, success would be a list of factors that we have learned, policy-based and financial factors that drove the projects in existence now, as well as policy and financial issues that potentially impede the broader rollout of solar at wastewater facilities, and some sort of learning from that, some sort of toolkit or menu of options that indicates here are the important policy incentives moving forward that could better enable broader scale adoption of solar at wastewater treatment plants.
And I guess I would say broadly, in my work, I'm always interested in working towards solutions, finding ways we can use different technologies, approaches to come up with environmental solutions. So that's the space I'm interested in here.
I would just add one more thing about just raising I mentioned earlier, and I keep kind of coming back to this, and I've been thinking about this in the relation between the kind of the laws that we have, the Clean Water Act, and its broad mission to protect water quality. But by being sort of uni-focused on water quality, granted, there's other components in the Clean Water Act that are important too. But there isn't an energy efficient or a resilience, climate resilience element to the Clean Water Act. So I think to the extent that we can, start to shift that paradigm to say it's okay to be, look at the benefits that you gain from paying attention to these other things that matter for your system, that can benefit your community in different ways. I think that we'll be making. I'd love to see us make some progress in that domain, and to me, that would be a measure of success.
Christine, Kim, Hannah, thank you so much for being on Growing Impact, talking about this project.
Thank you, Kevin. This was a fun conversation.
Yeah, thanks. Pleasure to talk to you.
Thank you, Kevin. Appreciate the opportunity.
This has been Season 4, Episode 2 of Growing Impact. Thanks again to Christine Kirchhoff, Kim Van Meter, and Hannah Wiseman for taking time to talk with me about their research. To read the transcript from this episode and to learn more about the research team, visit iee.psu.edu/podcast. Once you're there, you'll find previous podcast episodes, related graphics, and so much more. Join me again next month as we continue our exploration of Penn State research and its growing impact. Thanks for listening.